Yeah, here you mean?
Yeah.
Yeah, it's just my standard way of doing the SQL. Okay. That should work. All right. And it did it. Okay, very cool. So what we've just done then is we pointed at, so I went to S3 and preloaded this stuff. If you wanted to do it yourself, you go over to this tables thing and you do create table. I'll just do it. Select file, drag the files here, and then they show up in the system. Their UI is crap, because at that point, if you don't copy down the two paths it tells you they are in S3, you have to go manually hunt them down, which is what you saw me doing on the other one. So, why are you doing that to me? There we go. Yeah, I'm gonna do that. That's not what I want. There we go. So, in fact, I couldn't find them because you can't find them in the UI, so I literally had to go figure this command out so I could expose them where they were, because this is not an easy to guess value right here that they make up for it. So when you do the import, they make that value up and then drop your tables underneath, or your files underneath it. So I'm pointing at the tab delimited file. This is actually creating a thing called a data frame that points at the file. Doesn't do anything with the file, it's just pointing at the file. This is something that will then create a view of that file. So essentially we're moving the file away. Here this data frame is in Scala. This makes it now available, when we do this here, it's now available not only in Scala, but it's also available in R, Python, Java, but it's also available in this special SQL context, which allows you to do SQL queries against the data. And so we just literally, on a tab file, we just did a select star and filtered it on the zip code, and it came back this way. Okay. So, let me go back to where we were in the presentation, make sure I covered the thought. Oh, I know. So, nothing actually happened until this command here. So even though it looks like something happened here, it didn't. It just was an instruction to look at a tab delimited file. This is an instruction to say, I want to store it, but still nothing's happened. Here, this SQL isn't executed. Nothing happens here. This is just at some point when df is referenced, deal with this command, execute this command. Well, when it goes to execute this command, it will go, oh, we've got this blah thing, so then it will cause this command to try to execute, which will go, well, wait a minute, this hasn't been run yet, and so then it runs, sucks the file in, shows it into the temp table blah, actually executes the query, and then finally display receives it back. That's the chain. And so the important thing to get from that is that it's lazy. All of that's a lazy operation. So, okay, I think I covered that. Okay, so I don't think I can cover anything else in the next 15 minutes fast enough, so it's probably a good place to stop with this. Any questions before I dive off this UI?
What are you going to do now with the results?
How do you mean?
Like, now you got your results from your Spark queries.
Yeah.
What would be your intent to?
So all I was doing here was showing the CSV and the idea of filtering on a CSV. If we actually drop into the business problem that I was talking about earlier, I actually have got a set of tables that I've already set up.
So then you're going to put your data back in Postgres, or your results.
So yeah, so what's going to happen is there's going to be, I've got cron jobs running in Spark. One's going to go out and talk to this MySQL database they've got that one of the appraisal systems is in. And so it goes to this view and asks for the data. The data is timestamped. So they'll fetch, so to give you an example, there's some account number inside that appraisal system, some number that identifies. In the appraisal system, it really means this particular whatever appraisal, and here are it's a street line, and all of the addresses in just one line. And so that view will be something that fetches back, and it gets shoved into this source system identity. And so you can't see the other here, that's actually JSON. Can I quickly do the JSON? There is a way to do that, how? Okay, I'll be on a tangent if I do that right now. But, so this is the actual table it gets dumped in. So I have several different Spark jobs. One's going against that view on that SQL server. Another one is going against a folder. So when they drop files in a folder, they get sucked in. And so that actually generates a new source system. So here you can see order entry. Can you see this? I don't know how to, I do not know how to make this bigger. That is going to be a set of tangents, I think.
That's okay. I think it's readable.
Okay, hopefully it is. I'll have to figure that out for next time. So this is obviously when the Salesforce leads got dumped in. This is the date timestamp, but all this is made up right at the moment. This is the identity of the row, their actual source row. So it could be a single street line. Then this is an adjustment. So remember, the system itself is read-only. This is where the adjustment to fix it occurs. And then this is where the request is formed up based on the adjustment before it's sent to the SAS. And then this is what happens after it hits the SAS. And so each one of those is going to be a staging, a Spark cron job that's managing this input flow. And so that's where I'm at it right now. I don't have any of it. The hardest part is making up data at the moment. That's actually the hard part, is making up data to make these systems dump them in. But it's a insert-only, read-only database. So if the account pricing tool, that one, I go to the view, I get the entire data set every single time. So when I go to the view and bring back the data set, Spark is going to sit there and go, here's the data set we got last time, here's the data set you gave me this time, what's the diff, and then only insert what's left. Does that make sense? And so this is not sophisticated use of Spark. In fact, of all the things I saw last Wednesday, my application really looks stupidly simple. My data drip. I have a drip. I don't even have a puddle yet. So that covers that, and then we can go into a little more detail on that if you like before we finish. So any other questions before I drop off this UI? Y'all good? Or we'll go into more, yeah, actually that's going to be the next thing. I'm not here next month. I'm out of the country. So I'm not going to be running this next month. So I guess I need to know if people are going to be here. And if so, someone has to volunteer to at least do something. Otherwise, I'm going to have to cancel next month's meeting because I can't be here. So we'll talk about that in a minute then. Let me finish this. Okay, so, all right. So now maybe we can go back to your, if you've got any more questions about it and kind of your particular business problem. So,
I mean, the only reason I was asking is I was experimenting with writing CSV files out, and the way the data frame works, the data frame is actually partitioned. So if you try to write that out to a CSV, it's going to write it out to 100 files.
Yep.
Because by default, it's partitioned. Actually, I think it's 200 because the data frame is partitioned by 200. Which is annoying. But if you have Spark running on a cluster with multiple nodes and stuff like that, that's because the data is going to be on different nodes. And so I was just curious that if you're running Spark on multiple nodes and you're going to be writing to your Postgres, does each node, because it has its own subset of data, does each node hit your Postgres server to write that to the tables? Yes.
And so two things. If you want a single CSV file, you can actually call partition and then partition, and then you can actually pass the number 1 as a Spark step. And when you do that, it will actually take the 200 and force it into a single one before the write.
It does, but so then it moves all the data to one node, and now you're
yes.
And that just feels dirty.
Well, because a CSV is a single node operation, there's no way to. Now, if you were to set up a special process that was watching for Spark, meaning it could handle all the threads, and it collected the threads as they were finishing up, and then it dumped the file. You could do that, but that's special code. You have to write your own stuff. And
I saw a lot of people were using the Hadoop has a library that specifically for that will merge all files.
Yeah, yes,
And so they were, go ahead, write it, and then kick off something or in that same.
That does the merging.
Yeah.
Well, that's dirty too, because now you write a bunch of files and you just really noised up whatever your file system is.
You did, but at least you're not constrained now to memory on one node.
That's true. So in my case, I've got Postgres, and so every one of those, each one of the nodes is going to be firing their results into the Postgres. Postgres handles that just fine. And everything I do is all date stamped as part of the primary key. So because I'm insert only, basically I don't care how many nodes. And that was part of the design, so I had anticipated that so I don't have to deal with it. So, yep. Yeah. So I still, as far as your reporting problem, I would have to hear a little, I think, more details.
I haven't made a Spark for it, so I moved on.
Yeah. Spark is a sledgehammer on the problems it's good at. I'm just not sure it's really good at
well, and we have a puddle that we don't have a
right. So if I will say, if you were going to use Apache Camel and Java to, like at EXO, the telco I was at, they had an accounting system, a billing system. We had been fined $4 million by the state of Florida because we didn't do our addresses right, and they weren't auditable, and they go, you didn't tax right. Well, we probably taxed right, but we didn't know for sure. But now
we know where your SAS comes from.
What's that?
Now we know where you got this, where your SAS.
Oh, the original idea. I actually did the first version of it in 2008. I didn't do buildings, I did USPS street addresses, not realizing all of the dang problems that come out of that. And so yeah, I ended up doing that, and we even just with USPS street, so I just take an address, as long as the street was unique, I just created essentially a hash code for it. So I created the unique identifier for it, associated the two, and so you give me the hash code, I give you the address. You give me the address, I give you the hash code. Well, now Martin Luther King and Main Street give you two different hash codes, right? So it didn't solve that problem. But it did solve the 99% case, or actually it was 95% case, for this Florida audit thing. So what happened is, we created a folder in Camel that just sat there and watched, and they would toss us it was pipe delimited. We would then do the transform on the pipe delimited, and then we would separate it out into batches of 20, and each batch of 20, that was how one of the optimizations is, all 20 addresses could be submitted the SAS endpoint's able to take a batch. So it would take the 20, process the 20, take them back, and then all that would get manufactured. There would be errors, and we had special error logic. All this was being written in Camel and Java, and then finally dropped back on the file system as pipe delimited so that they can then go off. And so their pipe delimited input, they got the file back, and it was a copy of what they did plus the extension of all the columns, all the data that we'd fetched out. So that's how we did it. To do that job took Mamta and I 6 man-months. It was 6 man-months, and it was fragile, very fragile, because later if they came back and they said, you want another column, we're fiddling with the code all the way up and down the chain again. And so the beauty of Spark is that stupid logic for doing the cron job and actually firing it off, we had to go coordinate with people in IT to do that, right? So now there's no... The way I was explaining it to my buddy the other day is the reason Spark's popular, and I think it's going to get more popular, is it eliminates so many people from the coordination of trying to get things done in IT. Because as a coder, someone says to me, hey, we'd really like to be able to normalize the addresses and attach identifiers. I'm over to the billing team asking them to dump stuff in the data warehouse, and I'm trying to get the data warehouse to give me a view on the dump that I've gotten so that I can actually write the code to it. And then I'm going to write the code, and then I got to put the results somewhere, and then they've got all these people are coordinating everywhere to get this really simple, we just need this file extended with data that came from a SAS. And so so now I'm down to, I just talked to the billing team, they make me a view, and then everything just happens. That's it. I have me on my Spark cluster, and then as long as they can get me a view to their billing data, or they're willing to put it in this file at this one, S3, basically it's just going to get uploaded in S3. Everything else is going to happen magically, and they don't have to be involved. I don't have anybody in data warehouse team. I don't have to get anybody in the freaking, you want how many servers for that? Blah, blah, blah. I'm fighting and yelling at people trying to make something happen. The 6 months was miserable. And so now that process that Mamta and I took 6 man-months, and at least a dozen people throughout IT. It's down to one person and potentially as short as a week, 2 weeks. And I think that model is what's taken over. The fact that machine learning is in it, that's awesome, but I think that's an edge case. I still don't think that's the primary value that's going to end up coming out. It's going to be just literally doing the drudgery work, but instead of it taking 6-man months, it taking two-man weeks or person weeks, because we have sexist terms in our industry still. So, but okay. So, any other questions? Any thoughts? Cool. Was it useful? Is this useful? Do you want to go in a different direction in 2 months?
I'd like to see ACA.
Okay. Well, ACA, what do you mean? A demo of ACA? Or are you, how would you demo ACA?
I don't know. I've never played with it. It's on my list.
Well, I wrote I wrote with Scala and Akka, but I intentionally wrote I just used the standard Spray.io HTTP, and so I don't really leverage Akka extensively. In fact, to the degree Akka operates, as much as I could, I'd probably flip stuff into Spark and let Akka, because that's all Spark is. I mean, Spark in the implementation is Scala and Akka. It's just materialized for the kind of SQL query plan domain. And a lot of what I do is transform, so I would probably push a bunch of that into Spark. Yeah, I don't know that I would spend a lot of time in Akka now. I don't know.
Well,
I have to feel on that.
Spark.
Yeah, well, so yeah, if you're not going to use Spark, when I started, Spray.io was separate from the, it wasn't called Akka HTTP yet. That team was independent, and so I needed an HTTP server, and I didn't want all the overhead of play, so I used Spark, and then I used Spray, which is in Spark. I mean, not Spark. I used Akka, and then I used Spray, and so my server's highly scalable. It's teeny tiny. It's works wonderfully, and then I've got a multi-reader, single writer model, and so I've got it where it can expand and contract, and we've got servers. So basically, the reader servers we expand as many readers as we need. They're going against DynamoDB, and then I have a single writer. So if I need to put something in the database, everything's bottlenecked through that writer. But writers are very infrequent events, and so that model, there's always a single writer actor. There's never more than one writer actor, but there can be an infinite number of reader actors, and so that's all I use. So I don't really use it. I see lots of other people using it like, man, that's really complex stuff. I'm glad I don't have any business problems like that. So we can probably do a presentation on actors, but that's going to be involved. That's going to take quite a bit more focus. I don't think showing my stuff really shows actors, so I don't think it'd be very useful to show my stuff. I mean, I'm going to show my stuff eventually, just to the Scala group, to the Scala enthusiast group, just because I wrote it in Scala, but I'm not quite ready to do that yet either. Still self-conscious about my code. I want to get that shut off.
Have you found any sites that give you sample problems to solve, kind of like, there's that site that does 99 Scala problems by example. So we need like non-trivial problems, not stuff with foo and bar.
Well, that's why I brought mine in for this. I want real business problems to start solving, because quite honestly, it's not. I don't find it very useful to do little toy problems. I really want I want to see an actual CSV get queried and then pushed out into the database, which I was hoping we were going to get to push it to the database
Oh,
tonight.
here's one I solved in Java, and it took like forever to run. I mean, this takes like, I don't know, 30, 40, 50 an hour to run on a machine.
Okay.
You generate a billion random numbers, and you want to sort them all, and then you want to print out the top 100 or 500.
Okay.
That would be like a problem we could solve much faster with Spark, right? Because we could.
Yeah. Well,
we
that's
might be
small
able to.
enough. That would fit in memory. You could just write a Scala
it's too
app
big.
that would simply do that.
No, it won't fit in memory. And the JVM, it'll just blow it. I mean, the input file is like 3 gigabytes, I think.
Of random numbers.
Yeah.
3 gig. Well, I would
Well, okay, forget 1 gig or 1 gig of numbers, say 100.
Oh, you mean something that exceeds memory,
Yeah,
is really
something
what
that
you're
exceeds
saying.
memory,
I got
yeah,
you,
yeah.
yes. Okay, yes, then that would be a good problem for Spark. In fact,
Because the JVM I was running was communicating.
I think that's what the Hadoop test is. The petabyte test, or not peta, the terabyte test that they do to prove Hadoop speed, and then Spark did it, and they did it with 1/10 of machines, and
ran 3 times faster.
and it was, I can't remember, it was a ridiculous number of times faster. Like, wow, that's pretty awesome. Well, cool. I think we're done then. So unless anybody's got something to add or wants to volunteer to take care of next month's meeting. So I don't think we're going to meet next month unless somebody, I'm going to go cancel the meeting. That way people aren't showing up here. And thank you very much for the use of your mouse.
You're welcome.